This is my fifth and final video lesson for the unit periodic table. In this video, we will be determining the trend for electron affinity and summarizing and comparing all the trends on the periodic table. So go to page 21 in the class packet. Motivation. Why in terms of effective nuclear charge, metals have low ionization energy and electronegativity, and nonmetals have the opposite. Remember in the first video lesson, I mentioned that metals have low ionization energy and electronegativity, while nonmetals have the opposite. In this video lesson, we will explain that. Learning target. At the end of the lesson, I'll be able to explain the trend differences in metals and nonmetals and analyze the electron affinity trend. So homework will be number 5 Junipod. There will also be another quiz Junipod based off this lesson and the previous lesson. And then there'll be exam 3, which will be only based on the periodic table unit. So why metals have low ionization energy and electronegativity? You should know by now that metals tend to lose electrons, become cations. The reason for this is because metals have low effective nuclear charge in comparison to nonmetals. It is easier to lose electrons when you have a weak nucleus. For ionization energy, since metals have relatively weak effective nuclear charge, you don't need a lot of energy to remove the electrons. For electronegativity, with a weak effective nuclear charge, it's much harder to attract an electron in a chemical bond. Why nonmetals have high ionization energy and electronegativity? You should know by now that nonmetals tend to gain electrons, become anions. This is because that nonmetals have high effective nuclear charge in comparison to metals. It is easier to attract electrons when you have a strong nucleus. So for ionization energy, with a strong nucleus, it's going to hold on to electrons much tighter, so more energy is needed to remove those electrons. And with a strong nucleus, it's much easier to attract electrons within a chemical bond. Learning check number 1. Which two characteristics are associated with metals? Pause the video and resume once you have the answer. Okay, so here's the answer, choice 1. Low ionization energy and electronegativity. Learning check number 2. A diatomic element with a high first ionization energy will most likely be a what? Pause the video and resume once you have the answer. So high first ionization energy is referring to a nonmetal. In addition, you should already have memorized the 7 diatomic elements on the periodic table. They are all nonmetals. So nonmetals tend to have high electronegativity. So the best answer is choice 1. Now we're going to talk about the last trend, electron affinity. Keep in mind, electron affinity is not on the regions. Electron affinity is the change of energy of an atom when an atom adds an electron to form a negative ion. Basically, it's similar to ionization energy in which you form an ion, but this time you're forming a negative ion or an anion. So this would be the equation. So X is the element and it gained an electron, forming an anion. If you recall, ionization energy, you absorb energy in order to create the ion. For electron affinity, it can either be released or absorbed. But energy is typically released for electron affinity. The more attraction the atom has for the electron, the more energy will be released. So learning check number 3, electron affinity is the measure of the amount of energy released when a neutral atom in the gaseous phase does what? Pause the video and resume once you have the answer. So we're creating a negative ion. So in order to create a negative ion, you need to gain an electron. So choice 2. So here we have a diagram that shows electron affinity of each main group element. Notice that we have negative and positive numbers. I'll explain what the negative and positive sign mean in later slides. But for now, we're going to figure out the electron affinity trend. So we're just going to base it off the value of the electron affinity, not the sign. So based off of this, electron affinity increases across the period from left to right and increases from bottom to top. So it has the same trend as ionization energy and electronegativity. Now we're going to talk about what does the positive and negative sign mean. In science, if you see a positive sign next to a value of energy, it means energy is absorbed. If you see a negative sign, it means energy is released. So let's look at some diagrams. So here at beryllium, the electron affinity of beryllium is 18 kilojoules per mole. So notice you need to absorb energy for beryllium to gain the electron. For fluorine, energy is released when it gains the electron. So check of understanding number 1, which atom have more attraction for the electron? And how do you know? In order to figure this out, you need to look at the signs of the electron affinity values. Notice that beryllium is positive and fluorine is negative. One way to think about this is that since beryllium is positive, you need to use energy to make the beryllium take the electron. But for fluorine, you don't have the case. Remember, the more attraction, the more energy is released. So fluorine has more attraction for the electron than beryllium. Why electron affinity increases across the period. So in order to figure this out, you need to compare the effective nuclear charge and the shielding effect. You should know by now, within a period, the shielding effect is constant, but the effective nuclear charge is increasing across the period. So with a strong effective nuclear charge, it is easier to attract or gain an electron, therefore more energy is released. Why electron affinity increases up a group. So within a group, effective nuclear charge is constant, but the shielding effect decreases as you go up a group. So since there's less shielding of shells, it makes it easier to attract or gain an electron, thus more energy is released as you go up a group. Learning check number 4. As one moves down a column in the periodic table, electron affinity tends to what? Pause the video and resume once you have the answer. So as you go down a group, electron affinity decreases because of the shielding effect. Right, so the best answer for this will be choice 3 because it's the only one that has decrease. Learning check number 5. The shell electron structure of an atom with the highest electron affinity is what? Pause the video and resume once you have the answer. So based on the trend, elements with the highest electron affinity can be found on the top right of the periodic table. So we know 4 is wrong because 4 is towards the left. For 3, this is showing a noble gas, and noble gases do not make ions, so 3 and 4 out. So between 1 and 2, 2 is closer to the right, therefore the answer is 2. Now we're going to compare and contrast electron activity and electron affinity. People always confuse these two terms because they sound very similar and they have similar definitions. They also have the same trend on the periodic table. So for electron activity, you're measuring the attraction of bonding electrons in a bond, while in electron affinity, you're making an ion and seeing how much energy is absorbed or released in the process. This is a summary slide showing all the trends that we covered in this unit. To help you copy this without tilting your head, I'm going to rotate it down for you. So this concludes the video lesson for today. Remember to do the Junipod homework and quiz. There will be an exam on this unit afterwards.